Welcome back. In the previous session, we have dealt with some of the cases that comes under regression analysis. So let us discuss some of the special cases that comes under the regression analysis. The next one, how to get the regression coefficients from an equation. Previously we learned about identifying the regression coefficient, that means bxy and byx on the basis of certain values in x and certain values in y, and we learned how to substitute those details to a table, and from those table and we have learned how to substitute the total values to certain equations depending upon the nature of the question. So far that is as per the regression situation, but in this sessions onwards we will be discussing about some application level cases which you have to face with regard to regression equation. From that, one such case is you need to identify byx and bxy from a simple linear equation. So how we are going to find out? When the regression equation of y on x is expressed in the form of y equal to ax plus b, then a means this one. A is the value of byx. Remember, if you have come across the equations, and for every case regarding the same situation, like how to find byx and bxy from an equation, you need to assume that whatever the equation which you are going to deal, let the first equation be y on x, and we are going to prove whether it is y on x. And once you assume that it is a case of y on x, remember in the beginning we have learned about methods of least squares. This is the equation for the method of least square, y equal to ax plus b. If you can solve the given equation to this form, then you will get ax variable, and in that the value of a will be b by x. You will get a clear picture when we are going to deal with an actual equation situation. Anyway, understand the concept. For y on x, you will be using the equation y equal to ax plus b. Similarly, when the regression equation is on x on y, it can be expressed in the form of a mathematical equation x equal to ay plus b. Remember these two situations, then you will understand the concept. For the situation y on x, the equation will be y equal to ax plus b, and regarding x on y, it will be x equal to ay plus b. And whatever the equation may be, if you are getting ay, the value that represents a will be bxy. If it is a case of y on x, if the value of a, whatever the number it is, that will be the value of byx. So this is how you need to find the value of byx and bxy from a certain equation. For example, find byx from this linear equation 2x plus 4y minus 5 equal to 0. So finding byx comes under the category of y on x. See, equation y on x. So for y on x, the equation is y equal to ax plus b. So you need to change this equation to this form. This form means, see, in this equation you can see that y equal to ax plus b. That is, in the left hand side of the equal sign, y variable must come, and to the right hand side of the equal sign, ax plus b variable must come. So this equation has to be converted to this form. It can be done as like this: 2x plus 4y minus 5 equal to 0, which can be written as c y equal to ax plus b. Left hand side of the equal sign, it is y. See, the y variable is this one. See, 4y equal ax. Ax means whatever the number that is associated with x. In this case, it is 2x. So minus 2x, because when the number shifts to opposite side, the sign changes. Minus 2x plus 5. So we have changed this equation to the method of least squares equation of y equal to ax plus b. I hope you know why we selected this equation rather than this one. This is a case of finding byx. For finding byx, we will be using equation y equal to ax plus b. So For y equal to minus 2x plus b, if you can solve this equation, please simplify it. So it can be simplified as y equal to minus 0.5x plus 1.25. That is, if you shift this forward to the denominator of this side, that is minus 2x plus 5 divided by 4, it can be simplified as minus 0.5x plus 1.25. Try to simplify it as easy as possible. See, now you have converted the equation given in the question to the pattern of mathematical equation of methods of least square, that is y equal to ax plus b. See, this equation has been corrected to the method of least square equation of y equal to ax plus b. See, here the variable minus 0.5x represents ax. X and x remains the same, so the value represent a is minus 0.5. So the value of b by x is minus 0.5, whatever number associated with x. See, this is how you can easily identify the value of b by x from an equation. And similarly, you have to do the same in case of a situation where you might be assuming that the particular equation may be the case of x on y situation. You have to deal both situations, so familiarize the both situations and cases. Okay, next one, let us discuss the other case. Find bxy. Bxy means this one. If 3x plus 2y plus 4 equal to 0 is the equation of x on y. Usually in the question they may not specify the situation as x on y. Find bxy from the equation. That will be the given. So for finding bxy, you need to change this equation to the method of least square equation of x equal to ay plus b. See, x is the only variable that comes to the left hand side of the equal sign, and remaining all comes to the right hand side. So you need to make necessary changes in this equation where the number associated with x has to be come to the left hand side of the equal sign, and the remaining has to be come to the right hand side of the equal sign. So let us do it. 3x plus 2y plus 4 equal to 0, it was given in the question. So in order to find bxy, you need to change this one to this form. So x equal to ay plus b. Here x is 3x, so 3x equal to minus 2y minus 4. See, now this part is almost similar to this one, and in this equation you have to find the value of a. Here it is minus 2y, so the value or the number which represent a here is minus 2. And remember, try to simplify the equation as easy as possible. Here it is 3x. If you divide this section by 3, you will get x equal to minus 67y minus 1.33. Try to do this step because it may be confusing, but you have to do it compulsorily. So now you have the value of y as ay is represented as minus 67y. So the value of bxy is minus 0.67. So this is how you have to find the value of b by x as well as bxy from a set of equations given. Let us go to the next part. How to get mean of x and mean of y from the regression equation. Usually we have been computing mean of x and mean of y using the traditional arithmetic mean equation, because usually you will come across a question where a certain number of values of x will be given, a certain number of values of y will be given. You will take the total of x divided by number of items. That's why you have find the value of x or mean of x and mean of y. But if there is another method for finding the value of x, that is mean of x and mean of y from the given set of equations. So let us try to find out. So whenever you come across a equation, usually it will be a situation of linear equation consisting of certain x variables, y variables, numbers. I hope you all know how to find or how to solve a linear equations and finding the value of x and y. For example, here two equations are given. 2y minus x minus 50 is given, 3y minus 2x minus 10 is given. You need to find the mean of x and mean of y. It is quite easy. You just follow the steps of solving a linear equation and find out the value of x and find out the value of y. It's a simple method. We have been learning that part from the BNS paper. Finding the value of x and y from a linear equation is the very easiest method. I hope you all know how to find the linear equation for certain variables. Once you use the linear equation method for finding x and y, you will get x a certain value for as x and you will get a certain value of y, whatever the number you are getting. For example, if for this situation here, see, 2y minus x minus 50 equal to 0, 3y minus 2x minus 10 equal to 0. So by using the linear equation patterns, you can use any method. For time being, I am using this one. I am multiplying the first set with 2 and second equation, let it be like that. By solving that, I will get the value of y as 90. So the mean of y is 90. It's very simple. Just find the value of x and find the value of y. Whatever the value is getting, that is the mean of that particular variable. So y is 90. If you substitute the value of y in any of these two equations, you will get the value of x. See, by substituting this value in one of the equation, you will get x equal to 130. So the means of xi is 130 and mean of y is 90. That is the concept. It is very easy to find the mean of x and y in case of a regression equation. You have to be very familiar with solving the linear equations method. Here for the time being, I am selecting this one and multiplying such and such numbers. It's up to your discretion to solve the linear equation pattern, and whatever the number you are getting in case of y as well as x, that number will be the mean of that particular variable. Here see, y is 90, so mean of y is 90. See, it's quite very easy. So let us go to the next part. How to identify two regression equations. Okay. Until now, we have learned how to find bxy and byx and how to find mean of x and mean of y. If you look closely to the methods which we have learned or the steps which we have followed, you can see that in both cases we are making some assumptions. We are assuming that it will be like that and it will be like this. So since it is based on assumption, you need to make sure whether the equations given in the study, that whether that comes under the regression case. So let us deal with that part. How to identify two regression equations. If the product of byx and bxy is numerically smaller than 1, then the assumption is true. For example, if you have given two equations and we are assuming that let first equation be y on x, second equation be x on y. We have learned the similar pattern at the beginning of this session. Okay, so you will get value of byx and bxy on the basis of assumption. And next thing you have to do is that you need to make sure whether your assumption was correct. And how you are going to check that assumption was correct? Just multiply the coefficient of regression. Coefficient of regression means the value of byx and bxy. If you multiply these two numbers or values which you have assumed, if you get a value smaller than 1, then your assumption was right. Assumption means first equation was y on x and second equation was x on y. That was our assumption. But unfortunately, some situation you may get a value greater than 1. In that situation, your assumption will be false. False means I assumed that first equation may be y on x, second equation may be x on y, and when I multiplied I got a value greater than 1. So my assumption is wrong. When my assumption is wrong, you need to think in the opposite way. Opposite way means earlier I assumed that first equation is y on x. After the checking I found that my assumption was wrong. So now let us assume let the first equation be x on y, and make sure whether the second assumption is right or wrong. This is how you need to identify any equations or do regression equations. So let us try out, and these are some of the properties that is related to regression. We have learned an equation where finding the byx and bxy on the basis of correlation value as well as standard deviation of x and y. So if the r is positive, then both values, that is byx and bxy, will be positive. If the r is negative, then both byx and bxy are negative. So remember, byx and bxy will not be opposite sign. Opposite sign means one is negative and other is positive. It will never ever come like that. It may be either both of them positive or both of them negative. Remember, it's a rule. Sometimes you will be given two equations and make sure whether they are regression equation. In that situation, you need to make sure whether you are getting a value smaller than 1, or if it is one may be positive, other may be negative. In that case, it is very easy. You need not have to do any computation, because one is positive and another is negative, and you are asked to find whether it is a regression equation. Definitely you need not have to do any computation, because one can't be negative and another can't be positive. If a regression equation is correct, both are positive or both are negative. Remember that rule. And also we have learned that byx equal to r into standard deviation of x, y and standard deviation of x, and we also learned that bxy equal to r into standard deviation of x and standard deviation of y. So let us assume and multiply these two coefficients, that is byx into bxy. So if you multiply byx and bxy, you will get byx equal to bxy into bxy equal to r into standard deviation of y by standard deviation of x into r into standard deviation of x divided by standard deviation of y. So if you go through it, you can see that this one and this one will be cross multiply cancellation, and this one and this one will be cancelled. So the remaining value is 2r, that is r squared. So another equation, r square means byx into bxy, and it can be written as r equal to root of byx into bxy. So these are some of the main properties with regard to regression. Familiarize all these properties, because apart from dealing with a common regression equation case or a problem or application level question, you sometimes come across a question where a certain regression equations may be given. You are asked to find byx or bxy using any of these methods and make sure whether a regression equation is correct or not. And you sometimes they may ask question like that. So apart from learning that all the methods which we have learned previously, familiarize these steps, theoretical concept, these properties with regard to regression. So let us try out one case. In the study of a regression equations, following values were obtained. Regression coefficient of y on x. Regression coefficient of y on x means byx is 0.25, r is 0.42, standard deviation of y is 4. Find standard deviation of x. Sometimes you may come across a simple question like this. So on the basis of details given, you can see that we can use this equation. So byx equal to r into standard deviation of y divided by standard deviation of x. Byx is already given, 0.25 equal to r 0.42 into standard deviation of y, it is given 4 divided by standard deviation of x. By using the basic max, you will get the value standard deviation of x is 6.72. So this is how you have to deal with the simple cases with regard to the properties of regression. I hope you all guys are following the concept. And last but not the least, let us deal with another case. In a partially destroyed record of an analysis of correlation data, the following results only are legible. Variance is given 9. Regression equation is, two equations are given, regression equations are given. We have no information regarding which one is x on y and which one is y on x. You need to find out. And in the question you are asked to find means of x and y, coefficient of correlation, that is r, and standard deviation of y. So in this case, variance of x is given 9, regression equations, two equations are given. We don't know which one is y on x and x on y. You need to check. Find mean of x and y, coefficient of correlation, that is r, and standard deviation of y. So first of all, let us begin with means of x and y. We have discussed that one. It is very easy to find the mean of x and y by using the linear equation methods. Any method, whatever the steps you can follow, you can multiply any equation with any number, that is up to your discretion. Just find the value of x and find the value of y. Whatever the number that represents x is the mean of x, and whatever the number that represents y is the mean of y. So here the equations are 8x minus 10y equal to minus 66 and 40x minus 18y equal to minus 240. So by using the linear equation methods, you will get mean of x is 13 and mean of y is 17. I believe you all guys know how to find linear equation. That's why I am not showing the steps with regard to linear equation method. Try to find whether you are getting these answers or not. If you have any changes or if you have any queries, please let me know. So first part is over. Next one, coefficient of correlation. Coefficient of correlation means you need to find R. So how you are going to find R? The only information given in the question is two regression equation. How you are going to find R? It's very simple. First of all, find out bxy and byx. If you multiply these two, you will get R. Okay, so let's go to the second part. For the time being, you need to assume that let the first equation be y on x and the second equation, this one, is x on y. So 8x minus 10y equal to minus 66 and minus 8y equal to minus 16x 40x plus 214, which can be written as x equal to c for y on x. So for the time being, let us assume the first one is x on y and the second one is y on x. You can do any method. For the time being, I am assuming the first one as x on y and the second one as y on x. So as per the x on y situation, you means x equal to ax plus b. So x equal to ay plus or minus b. So x equal to 10 by 8 y minus 66 by 8. Here it will be y equal to ax minus b. So it will be 40 by 18x minus 214 by 18. By solving that, you will get b by x. Solving means it's very simple. Whatever the number associated with y, that will be the b by x. So here it is a 10 by 8. So b by x is 10 by 8. Here whatever the number that is associated with x, that will be bxy. So 40 by 18. And wait, make sure whether your assumption was right. For that, you need to multiply these two values. The product of coefficient of 10 by 8 into 40 by 18 exceeds 1. We have learned that if you multiply these two coefficients, if you get a number greater than 1, then your assumption is wrong. So our assumption was wrong. Now let us assume that, let's assume the other way. Other way means here I assume that first equation is x on y. So let it be y on x and second equation be x on y. So let first equation be y on x and second equation be x on y. And for time being, I'm not going to that part. You need to follow the same step again, and from that I got that byx is 0.8 and bxy is 0.45. If you multiply these two values, you will not get a value greater than 1. So our second assumption was right. Please try to do these steps whether you are getting this 0.8 and 0.45 or not. So once you found byx and bxy, you can easily find the value of r. We have learned that equation previously. I hope you have gone through that part. Just try to do it yourself. I'm not going to explain that step again and again because it's a lengthy process. So by using that equation, I found that r equals 0.6. So make sure whether you are getting the same answer or not. So we have found coefficient of x as well, x on y, as well as coefficient of y on x, at the same time correlation coefficient. So second question is over. Finally, standard deviation of y. In the question, variance of x is given 9. Variance is 9 means standard deviation will be 3, because always standard deviation square means variance. So variance of x is 9, that means standard deviation of x is 3. And we know that byx is this one and bxy is this one. So substitute in any one of the equation. For the time being, we are using byx. Byx equal to r into standard deviation of y by standard deviation of x. And byx equal to 0.8 equal to r is 0.06 into standard deviation of y, we don't know because you are asked to find that, divided by standard deviation of x, here it is 3. By solving this part, you will get the value 4. So this is how you need to deal with the application level question, where we have discussed or dealt with many of the properties which we have learned previously. So sometimes you may come across a question where all these properties has to be used, or sometimes you may be asked individually. So anyway, you need to, the most important thing is that you need to familiarize each properties, each cases which we have discussed. Try to identify and understand each steps. So just go through all these steps. We will discuss about the next modules in the next sessions, and try to understand each step. If you have any queries, please let me know. Thank you.